Okay, everyone, welcome back to week 3, part 2. Today we'll be going over equivalent expressions. Now, this is where SAT math can get a little bit more tricky with a lot of these more difficult questions you have to think through. Because a lot of these have variable constants, you can't exactly just use Desmos to, fly your way through these. You're going to actually have to know how to solve these out manually and conceptually, which is why, obviously these are a lot harder to do. And that's what I'll be covering today. So this question here is value of AB. We have this long expression here, ax plus 3 times 5x squared minus bx plus 4. That's equivalent to 20x cubed minus 9x squared minus 2x plus 12. And we don't know what a and b are, but we do know, we have to find the value of AB, but we do know that these expressions are equivalent. So that's what we'll do here. So again, this is our expression, and to find a, we can actually just multiply ax and 5 squared, and we know that's equivalent to 20x cubed. So we can find out pretty quickly that a equals 4, and we have to find out b. So we're going to have to multiply ax times negative bx, which is that middle condition there for the second expression, and 5x squared minus bx plus 4, and that equals negative abx squared. Now, we're also going to have to multiply this by 3 times 5x squared because they both have the same x exponent, which is x squared. So we're going to have to, add these together, and we can do this by factoring it out. So we have negative ab plus 15 times x squared. So we know that this is equivalent to negative 9x squared, which also means we can just get rid of that x squared and do negative a times b plus 15 equals negative 9. I accidentally left that x squared in there, but yeah, it's not supposed to be there. Then we just plug in 4 into a, and it is negative ab, so we'll have negative 4 in there instead. And, solving for b, we find that b is 6. Now, obviously, a times b is 24. Okay, this one, you have to be a little bit more conscious of your exponent rules. But we have root x to the 5th over cube root x to the 4th equals x to the a over b. Now, x is positive, which helps us out there. But what we have to do is we have to manually convert these roots into fractional exponents. So the way we can do that is, just have the inside times that 1/2, which is that 5 over 2. And this time, this is a cube root, so it's the 1/3. So we'll do that 4 times 1/3, which is 4 over 3. So once we do that, we can do the exponent rule where we just subtract 5 over 2 minus 4 over 3 is the same as 7 over 6. So that is equal to our a over b. Okay, value of RT. We have 2 over x minus 2 plus 3 over x plus 5 equals Rx plus t over x minus 2 times x plus 5. And everything that's over 2, and then we have r and t that are constants. So what is the value of RT? So we just, start off with the original function, and we can multiply both sides by x minus 2 and x plus 5 in order to get rid of all the denominators. So once you do that, the right side, completely cancels out, and this left side, we have 2 times x plus 5 and 3 times x minus 2. And we can just simplify it out and combine like terms. And we're just looking for, again, r and t. But we do know that we have 5x plus 4, which is the same format as rx plus t. So in this case, r equals 5 and t equals 4. rt equals 20. Okay, again, this is another one where we have to know our fraction rules. That parentheses does matter, so that so those exponents aren't just applied to the variable. In this case, we have our two, the function we're given, that's 70n to the 1/5 times 70n to the 1/6 times, or to the second, and that equals 70n to the 30th x. So we need to find x. So again, just simplifying it out, when you have an exponent of an exponent, you can just multiply those two, and that 1/6 times 2 equals 1/3. And then from here, again, you can just add the 1/5 and 1/3, and that equals 8/15. Now, once we have that, to find that x, we can kind of just disregard the base and just focus only on our exponents. And we have 8/15 equals 30x. Solving for x, we just divide by 30. That equals 450, sorry. And that simplifies to 4/225. Okay, questions like this are very, very common. Which expression is equivalent to? And then they'll show some sort of fractional expression. These are very, very common in the SAT. And it can help with Desmos, but you also want to know how to solve it manually. So we'll start off. And just like the question before, we want to get rid of our denominators. So what we'll do is we'll just multiply both sides by the opposite denominator in order to get rid of the function. In this case, we can actually just combine this function. And once we have that, we can just simplify the top. So we'll have the 4x, or the 4 distribute to the x plus 1, and then the -1 distribute to the 4x minus 5. And that will just equal 9/4x minus 5 times x plus 1. Okay, which expression is equivalent to 42a/k plus 42ak, where k is greater than 0? So, same thing that we've been doing. Kind of just wanted to have the same denominator on both sides. So we'll just multiply this right term by k/k. And then that way we can just combine the numerators with the same denominator. And once we simplify this out, we can actually just distribute the 42a out, and we'll end up with k squared plus 1 times that 42a/k. Okay, this time we have f of x over g of x, and we have to just plug those in. So again, f of x just equals x cubed minus 9x. G of x equals x squared minus 2x minus 3. And again, once you have an expression like that, we have to do some sort of factoring. So once you have this, again, we just want to factor this as much as we can. So the top, we'll just factor out the x for now. And we know that x squared minus 9 is also factorable. So then again, we can just factor this to x times x minus 3 and x plus 3. And the bottom will have x minus 3 times x plus 1. Now once you do that, we can just cancel out the x minus 3's on the numerator and denominator. We'll be left with x times x plus 3 over x plus 1. Okay, again, this one's more exponent rules, but this one's a little bit trickier. Simply because we have another dimension we have to account for, which is that t equals p to the 3n minus 1, and we have to find n. So again, just like before, we have to simplify that cube root p squared. And to do that, we have to, just multiply those two. 2 times 1/3. And we have to plug in that t. So again, an exponent of an exponent just means you multiply. And again, in this place, we can just disregard the base because they are the same. And we have that 2/3 equals 3n minus 1 times 9/7. Now, we don't need to distribute. We can just divide by that 9 over 7 first, and we'll end up with 3n minus 1 equals 14 over 27. Then, just solving for n equals 41 over 81. Okay, which expression is equivalent to y plus 12 over x minus 8 plus y times x minus 8 over x squared y minus x, or 8 times x times y. So for this one, we have our initial, and we have to just try and factor out the bottom to get rid of anything. Now, that x minus 8 is some indicator that we can remove it, or just, find a way to distribute it out. And we can do xy times x minus 8. In this case, this can actually simplify a lot, and the y's cross out and the x minus 8's cross out, just to leave us with 1 over x. So once we have that, we have y plus 12 over x minus 8 plus 1 over x. Now, just like before, we'll multiply both of these by the opposite denominator. And once we do that, we can just simplify it out to the same denominator. And we can distribute that x to the y plus 12 and that 1 to the x minus 8. And once we add everything up, we have our answer xy plus 13x minus 8 over x squared minus 8x. Okay. One of the factors of 2x cubed plus 42x squared plus 208x is x plus b. We're not exactly sure what, but we do know that the smallest possible value of b is the correct answer. Meaning, we're going to have some sort of factor be x plus something, and we want the smallest value of b possible. So we can just take out 2x, which leaves us with a much simpler and easier to factor expression. And you can do a little bit of trial and error, but I'm just going to do it for the sake of time. We have 2x times x plus 8 times x plus 13. And we, again, need that smallest factor. And in this case, 8 is smaller than that plus 13. So b equals 8. So that is it for this week's lecture. Again, these questions are all pulled from College Board. So these are all questions that have been on former SAT exams. If you have any questions, feel free to leave some in the comments below. And if you enjoyed the video, please like and subscribe.